Can you hear me? Hey, can you hear me in the back? Because the neat thing is when you're in the back, we can hear you in the front. This room has really weird acoustics, and it's actually not made for these fancy things. It's made for like normal conversational tone, and so it's got this weird thing with these domes. The sound carries, and one, it makes for kind of weird acoustics from the ceiling because of the speakers, and we're trying to figure that out. But it also means like when you're in the back of the room and it feels like you're half a mile away from the speaker, you can actually have a conversation with the people in the back, and they can hear you up here. So please be polite as you're moving in and out of the room. In the continued announcements of being a dick, alcohol. Yay, alcohol. Most people generally agree it's a good thing, except when you know, say you go to your local neighborhood bar and you come rolling in with a case, you throw it on the countertop. Local neighborhood bar usually doesn't like that and will tell you to GTFO. So will the hotel bar. When you show up with your own alcohol in the lobby bar, they will ask you to GTFO. And yes, if you're stubborn about it and they don't like you, they will ask you to GTFO from the premises, which isn't good if you're staying here or in general at all. So we prefer you not to bring your own liquor to the hotel bar. The hotel will enforce it. It's a law, not a hotel policy.
Not just the bar. I mean, the rule does apply to any public area.
Any public area. All right. Noise. Yay, noise. There was some party shut down last night because of noise. Probably will be again tonight. My recommendation to you is if you want to have a party and you want it to last longer than half an hour, keep the noise down. Don't turn your room into a club. It's really simple. And for the third thing that I'm afraid will put more ideas into people's head than stop the problem, please stop stealing do not disturb signs. Someone apparently is 6 and thinks it's a good idea, and now everyone else is going, excellent. But please don't do that. Leave the hotel alone. Leave the other guests alone. That's all I had on the being a hard ass announcements. On the slightly more friendly announcements, all wristbands are gone. It's not nearly as friendly as I wanted it to be. If you're not going, you can turn the wristbands into reg and we'll find friends for the wristbands. See previous statement about alcohol and people liking it. Tonight at 6 p.m. in the Build It room. That one over there. Marcia Hoffman will be talking about the recent U.S. versus Jones case on GPS tracking. That way, Build It. Marcia will be over there. Fire could have stretched before this point, but now I'm done. Now we're good? Oh, jeez. Anyway, I lost everything. Yay, let's hear it. Yay. I'll get out of your way. Thanks.
Berthaume. I'm probably the only person here that can pronounce my last name. It's all right. I work in the Washington, D.C. area at a large financial institution. Some of my coworkers are here today. Thanks for coming out. Yeah. Slides stopped working. That's strange. Wouldn't work without a Mac. In the past, I've done research on HTML5 problems, some stuff with browser fingerprinting, using standard deviation. Fire talk a couple of years ago. I don't know if anybody actually came to that, but I did that here. Backdooring, things people use for common trusted applications like OpenSSH. Other stuff. Also interested in stuff like critical thinking outreach programs for education programs. James Randi Educational Foundation, if anybody's familiar with it. The Center for Inquiry in Washington, D.C. I work with them sometimes. Amateur astronomy and cartography, which is maps. All right. And my presentation today is on backdooring Java, archive formats and whatnot, and using that to do cross-platform and framework abuse, using some of the APIs there. First part is going to be on backdooring Java archives. This is nothing new. Nothing in this talk really is, but I just wanted to walk through some of the steps of doing this and introduce a couple of tools and scripts I've written to automate the process. Okay. Disclaimers, as I said, nothing in this talk is new. I'm not a very good Java coder. I basically picked this up because Java is a great thing to abuse. It's on so many different systems. It's a great attack vector for penetration testers, and it's used to distribute malware. I think it's #1 at this point as a distribution method, either being exploits or just by clicking OK. All right. Opinions in this presentation are mine and mine alone, not the opinions of my employer or any of my friends or anybody else. Right? I don't have any affiliation with anybody else in this project, so anything done here is done entirely by me. I tend to ramble sometimes. I go off my slides, so if you think I'm going too far away, just raise a hand or something. Okay. Thank you. All right, and the purpose of this demonstration is to change Dama's image from this, the Juan Valdez, to the jackass it really is. Okay. Okay, first one, part 1, adding backdoors. Okay, Java's got a number of different archive formats. I'm not going into any of the things like Android archives, ADK, or, yeah, that's right. At this point, I'm just going to go with stuff in the standard J2SE and J2EE archive formats that are commonly used out there. First being EAR for enterprise, alphabetically. Second being JAR for Java Application Archives, and WAR for Web Application Archives. I'm going to go through the process of what you need to do to backdoor each one of these. Some are easier than others, and some are a little better than others for doing this with. Basically, enterprise archives are done by things running J2EE support, like JBoss, EAS, versions of WebSphere and whatnot. Tomcat typically run these things for large-scale enterprise applications, providing services and whatnot. JAR files, these are the ones we probably run across the most common out there. They run client-side typically on a person via the JVM on their system. This is where most of the attacks typically delivered to clients come from. And then WAR files, these are simple web applications, typically run on the same platforms, Tomcat, JBoss, WebSphere, but they're standalone, simple web application archives. Okay. All right, I'll go through the basics of these two because these are the ones that you'll run across the most often. All right, JARs are Java archives. They typically run client systems. They're zip files, tar files with metadata, Java bytecode for use in applications, and they can be digitally signed. To get elevated permissions, typically you'd want to digitally sign these, either by self-signing them or using a certificate. This is done by a lot of different attacks out there, Metasploit, SET, and whatnot, have facilities for doing this. WAR files, these are typically run on the application servers. Administration consoles are almost always WAR files that I found. They are easily uploaded, deployed, if you've got the ability to do so, and they run with the privileges of the JBoss or Tomcat user on the given server. Okay, they can also be digitally signed. Though on most application servers, to get full privileges, they don't require digital signing, unlike on the client side. Okay, so common uses. They can all do the same basic tasks on the server or client system that they're running on. They're used all over the place. I see them on administrative consoles I mentioned, SSL VPN clients, Barracuda, SSL Explorer, different systems like that use JAR files for allowing people to do their VPNs into work. And the great thing about them is, if you're able to co-opt that, you've got access to both the client system and you could actually bridge the connection, for instance, and get into somebody's corporate network for as long as they're connected to it using one of these systems. All right, IRC clients, there are a few of these, and I'll show you one of those later that I actually used as a basis for testing this. Okay. Applications typically are WAR or EAR file. Enterprise size stuff, financial institutions use EARs a lot. For thick or thin clients, they have different security methods in them and a whole bunch of different features that I am not fully familiar with all of them, but needless to say, they're out there. And that's actually a great thing to attack if you're going after stuff, because they tend to have a lot of interesting data associated with them. Okay. I've run across Java implementations for just about everything, from things like Burp Proxy, which is arguably one of the best things for reverse engineering stuff on the network right now, to IRC clients, as I mentioned, to things to actually control coffee machines, and everything in between. All right? And this is why they're targets for abuse, as I said. They run typically with full permissions of the user. If somebody clicks OK, they show very few warnings. They don't show you, like you would get on, say, like a phone, what permissions they require, typically. They will basically give you a Boolean whether you want to run it or you don't. If you don't, it probably won't work. If you do, it will. That's it. You're not given a lot, other than maybe the certificate chain associated with the self-signed certificate. Okay. And maybe if you open a console, you might be able to see something if it's outputting that data. Okay. If you self-sign, or if you sign from a certificate authority, the number of warnings are typically reduced, and you can get greater permissions on the client side. As I said, on the application server side, you don't typically need that. And this is rehashing everything that's already well known out there. One thing I find interesting is if I rebundle a jar or a war with something that's flagged by every antivirus out there, just about. But if I just rebundle it, add my class library to it, I almost never get the AV to pop on it because of the way they're doing their analysis. They're simply doing signatures on the jar or maybe the main class, but never when I bundle it in with another jar or war file does it seem to trigger, even if I'm running that code. Now, heuristics, I don't know why that is. Maybe they're having trouble getting a license to run it, or maybe they just don't want to take the time to look into the execution flow. It could be any number of things. Let's see here. Next. First, I want to go through and talk about using backdooring different payloads, adding different payloads to stuff. You can do file droppers. This is a common one. So you have a jar where it drops an exe, and then it executes it on the file system. Now, the problem with that is if you drop an exe, as soon as you run it, if an AV's got a signature for that exe, it'll probably flag on it. Okay? So you want to avoid that. If you've got the jar to run and it hasn't flagged on it, you can do a lot of stuff, just about everything, if you take the time to actually engineer, what calls you want to do, what operations you want to do. You don't have to do anything special. Dropping EXEs is kind of a bad way of going about things, in my opinion. Okay, you can pull data. If you've got full access to the system as the user, and you can pull whatever data that person has. JVM's got a lot of facilities to read, execute, interpret stuff, however you want, and just pull it back. Okay. I like using Meterpreter. It's not fully featured yet, but I've been adding some stuff to it, at least in my personal repo, to give you a little more functionality. I've been trying to reproduce some of the post-exploitation scripting that is in the standard Win32 Meterpreter. War files. These are really great because how many of y'all are pen testers? Y'all come across Tomcat or JBoss or WebSphere a lot? Now, how many of those have administrative consoles that are typically enabled by default and still use a default password? Never? Yeah, it never happens. Because if that happens, or if it has an easily guessed password or something allows it, say it's running Tomcat 5.5, allows you to upload whatever you want to it, you can add a war file to it. You don't have to sign it. You can just upload it, and you just call it. And your code is executing on that server in the context of the user. On Unix systems, it's usually running with a non-privileged user account, though I see it run it as root every once in a while, maybe a third of the time. And on Windows system, I almost always see it running a system. So there you go. You've got access to that system. Once your system, you've got what you need, right? Okay, so uploading it is dead trivial via the administration console. Now, if they've maybe disabled upload, you can change those settings typically from the administration console. And the one thing that I found is really funny, a lot of them don't allow you to change the password in the administrative console. You actually have to edit a file on the file system in order to do that. Yeah. EAR files, these are basically enterprise applications. They have multiple security layers built into them. They're usually given the feature set of the J2EE. They have resource adapters designed to give applications the ability to do interfacing with things like SOAP services, distribute their own jars for thin and thick clients, which is really nice if you can add a jar to an existing enterprise application, distribute that, maybe add a little backdoor to that. That'd be really nice, right? These can be updated dynamically. Typically, you can do individual components to them versus doing the entire archive. You can add wars to these things. So just like you could upload a regular war file to administration console, you can also add a war file to an EAR and call that. And that's actually my vector for backdooring in this context. Okay? I've seen a lot of financial institutions using EAR-based applications for their end users. I've seen collections agencies using it, credit card companies, and so on and so forth. Adding content to war files is the first one. This is the easiest by far. Basically, you just unzip, add your code to the classes path. You don't actually have to use this directory, but you can use wherever. Edit the file, add a new mapping for a URL you want to call to trigger the backdoor, save it, wrap it back up, and upload it. You can overwrite an existing one or make a new war file there. I say don't overwrite the administrative console. That might break things. But you can always overwrite something else or add a new one with some cryptic name, say jboss-admin-2 would be a good one. And then you can call that pretty easily. Now, all you would have to do to call this interpreter, which is what I'm using here, is call /backdoor. That's it. And your code will execute. And always, it'll be there in the background. It'll execute a new Java instance. It'll run in the background. And nobody's the wiser unless they actually go through and inspect what these things are. Maybe they scan the disk and looking for this thing. I've never seen this get triggered by AV. All right. Okay. Adding to EAR files. This is a little more complicated. Basically, EAR files, because they can be dynamically updated and they tend to have a lot more customizations to them and sometimes a lot of configuration after the fact, you have to do a little more work, and it may be better just to use a war file if you're given the option. But what you can do here is you add an application.xml, or you edit the existing application.xml, add your path to, say, a war file that you've added to the program, and then you can call that, say, by calling backdoor.war. Sorry. Notice right here, there are security considerations. These are defined on a EAR file basis. They can be named whatever they want. Typically, I've seen them named admin or root. You can override those contexts. If you've got the ability to upload stuff to the existing EAR file, you can change the security context of whatever you're executing. So you can do it as the full permissed user on the given application. All right. This is a very basic example, but you can add as I said, a new application.xml or extend an existing one. There are a few caveats with this. Sorry. As I said, you may not want to screw with these as much if you can just upload a war file to an application server, because if they run an EAR, they are more than likely to be able to run a war file because it is a component of the EAR, right? Thanks. Anyway, move on to jar. Okay. Jar, this is the most difficult one to backdoor, at least from where I'm sitting. It doesn't have the same ability to call URI path because it's client-side typically. You're usually given a single main class or main path, the entry point when the thing is executed. So pretty much you're given one class and execute, and then if you want to have it run something else, it either has to be referenced by something else inside of that archive, right? Well, say you don't want to go to the trouble of decompiling the Java bytecode, adding something to change the path mapping, adding a fork or whatever. Well, it's pretty easy just to add a new main class with a small chunk of Java and have it fork for you. So all you do is add a new one with a little snippet of Java that calls that jar again and executes the previous main, the application that you were taking over, and your backdoor. The really nice thing about this is, the way I'm doing it, it won't shut down the existing jar instance, the Java interpreter, for instance, when you exit the application, like you have a problem with other servlet or jar attacks that I've seen in the past, because I'm calling the Java interpreter again after the fact. Okay. Basically what I'm doing is I'm seeing what the path is to typically the temporary directory that the jar is executing in and calling another instance of the engine or the applet with an alternate class path in 2 cases. Okay. Okay. Now, I wrote a tool to automate all this. I'm doing war files, ear files, and jar files. Okay. Doing this manually can be the pain, zipping it up, calling the JDK to re-sign it if necessary or whatnot. So I wrote something in Python. It's kind of sloppy, but it does work with the Java interpreter with a few jar files and war files and ear files I've tested. Okay. And it works on everything from 1.4.2 and above. I haven't tested with 1.7 because that's not really in the end user runtime distribution mode yet. They're distributing that to developers, but it's not the main Java download if you go to Oracle's site at this point. Tested on Windows and Linux systems. Should work on anything that runs the full JVM. And I got some success working with the Open JDK as well. So, all right, I've tested with all these. It does require the JDK at this point. I haven't gotten to the point where I've been able to step aside and avoid using that entirely because I have to compile the backdoor as I'm adding it for jar files. Okay. You can change with configuration settings, the locality settings, and the certificate. So if you want to change the company name, say you've got a different URL, say WebEx2 or something of that nature, as the common name, you're able to do so. So rather than saying WebEx, WebEx does use jars, and I've actually been able to backdoor some things used by those programs as a backup for their meetings. Okay. Additionally, you can use, if you've got your own signing certificate that you want to use, a legitimate one, I give you the ability to add it there. Now what I did when I tested this, I used an IRC client. It's an open IRC client with a free use license. CBIRC, you may or may not use it. I use IRC a lot. I'm kind of an addict. Got a problem. It happens. And what I did is I made a copy of it, added a Java interpreter as the alternate entry point, and launched it and the main one from the existing application. As I said, when I was doing my testing, I found that when you shut down the main applet, main application, unlike with some of the existing Java attacks, it doesn't close out the backdoor. So it's persistent after the fact. So if they close their browser, it's still running. Okay, and here's an example. I did through the skitter last night, but got my callback and the IRC client triggered at the same time. All right, now part 2. I'm going a little faster than I thought I would. Okay. After I used raw jar, I was like, well, I want to do this. I do want to do more. I demonstrated this about 6 months ago at a local security group, Nova Hackers meeting. And I was saying, what's next? Where do I go from here? Well, I wanted to go and see what I could do to extend our execution to other frameworks using some of the APIs that are either included in Java or some of the things that have been made available by developers out there. So I could do things like post-exploitation scripts, as I mentioned. So this was a little arduous. It took a little time to go through these things because I'm not a Java developer. Basically just like screwing with it to see what I can do. So I went and started looking at the documentation for the native Java interfaces that I could start doing this stuff with. All right, and there are a number of these out there. Some are deprecated. Some of them are started support in 1.5 or had features added to them, and they kind of work, I guess. It's called the one I came across and I looked into and I tried to get working extensively was the JNI. A lot of people said they've had some success calling localized things on systems like Win32C calls using the JNI customized and whatnot, using Java 1.5 and later. I had a lot of problem with this because I'm really not good at Java, and I couldn't for the life of me get this to work even with some of the examples out there people have placed. So I was nearly about to give up on doing this. But then I came across, and I figured, I'll look out there, see what else is available. And I found something else. And this is one that I should have looked at first, but I wanted to stick to pure what's in the JVM, not use anything external, not bloat up my packages at all, not add additional classes. So after I looked into it, I went and started looking into something called the Java Native Access. It's a open platform, open source utility out there. It allows you to go and basically call different native APIs from Java. It requires full permissions and assigned applet if you're using a jar file to execute. But most things that are fun, you have to do that anyway. All right. Lots of different things out there use it. Log4j I mentioned, JRuby. Both utilize this to do some of their operations. Depending on what you're doing, it can be about 500K to a megabyte of additional stuff inside of your jar file or your war file or what have you. But it allows you to do a lot of stuff. There's documentation out there for calling just about every API. And I tried a lot of that and met with some problems. Okay, I tried again using the Java interpreter and had a lot of problem with seg faults crashing the JVM when I was trying to do native C. Yeah, that was a problem. Kept trying. Eventually I went on and said, hey, I'm going to try something else. So I figured, hey, why don't I try a managed code environment? .NET, it's on a lot of systems we go after, for instance. I can call it. It's not going to seg fault, hopefully. But I couldn't do some of the stuff that I was initially intending to do, like traditional DLL injection. So banged my head against this for a while. Got really pissed off at it. Eventually, I just said, okay, what can I do with the .NET? And after watching something at DEF CON last year by John McCoy, he did some really interesting stuff with .NET, some of his applications, but I wanted to move beyond that. I tried to recreate some of the stuff that I was working on there. And okay. Thanks. Yeah, I toyed with some of the stuff he had done in that presentation. Tried to do some enumeration. Got to the point where I could do lookups of different processes, see what their permissions were, whatnot, do execution of EXEs, call things in the framework. I was able to get that far. still trying to get around, and I was using the JSON, which allows me to do stuff. I could test stuff a lot faster. I call it directly from the JVM and call the stuff inside of .NET pretty quick, easily. I wouldn't have to restart, rebuild my jar file or whatnot every single time I wanted to call something. Right. Use that to test some APIs, enumerate processes, as I said, execute stuff. I got to the point where I was about ready to try some injection, but then ShmooCon happened, and that's where I am. Pretty much from right now, I'm trying to get to the point where I can inject the assemblies directly into the .NET, call a piece of code in there, but I haven't gotten to the point where I can actually do that yet. I'm looking for people to help me out with this, because I'm not a .NET developer either. Okay. Ultimately, I'd like to go back to C and make calls to do your traditional DLL injection, thread injection into Win32 processes. If I can keep it from crashing every time I'm trying to do this, maybe I'll get along a little better. But the moment I've got to the point where I can call managed code pretty effectively, do standard calls, that's pretty much the limit of where I'm at. Okay. All right, here's my references. GitHub, stuff we posted up there. I'm looking for people to help out if necessary. So, questions? Get a little while, I guess. It's a little faster than I thought it would. Boris? Where's Hackett? What? What? Hi.